Next, we're going to solve systems using elimination. We use elimination to get rid of one of the variables and solve for the other. And then just like in substitution, we'll plug that back into the equation to solve for the remaining variable. So what I want is for two coefficients to match up with each other but have opposite signs. So these two already have opposite signs, so I'm going to multiply both sides of the equation by 2 so that the y will be eliminated and I'm left with only x's. So I'm multiplying this equation by 2. So I get 4x plus 2y equals 14. Now I add these two equations together. I end up with 5x. The y's cancel out, and that is going to be equal to 20. Dividing both sides by 5, we get x equals 4. Now we can plug that 4 into either equation to solve for y. I'll plug it into the first equation. Two times 4 gives us 8. Subtracting 8 from both sides, we get y equals -1. So the solution to this system is 4, -1. They're not always going to be as easy as just multiplying one equation. In problem 2, we're going to have to multiply both equations. I'm going to try to cancel out the y's because they're already different signs. But the least common factor is going to be 6. So I'm going to have to multiply to turn this y into a -6y. So I'm going to multiply by 2. This one I have to multiply by 3 in order to turn it into a positive 6y. So I will rewrite both equations, multiplying the top one by 2, the bottom one by 3. And the bottom one and now our 6y's will cancel out. We end up with 29x equals 0. So x equals 0. Now I'm going to plug that 0 into either equation. I'll plug it into the top equation. 4 times 0 minus 3y equals 9. -3y equals 9. Divide both sides by -3 and we get y equals -3. So the solution to this system is 0, -3. You'll see that you will come across systems that have fractions in them. I personally am not a huge fan of fractions, so the first thing I'm going to do is multiply both equations just to get rid of the fractions. So I'm going to multiply the top one by 2. The bottom one I'm going to have to multiply by 6 to get rid of the fractions. So I'm going to rewrite these equations. And multiplying by 6, we get 9x plus 4y equals, and I'm not going to do 17 times 3 in my head, so I'll grab my calculator. We get 51. Now we can determine how we want to multiply in order to get a factor to cancel out. In my opinion, the easiest factor to cancel out is going to be the y's, because I only have to multiply one equation by a -4. So I'm multiplying this equation by a -4 and I get -8x minus 4y equals a -48. Now I can add these together and I get x equals 3. Now I'm going to plug that 3 into either equation. I'll plug it into the first one. Subtract 3 from both sides. multiply both sides by 2. So the solution to this system is 3, 6. Now this last equation would be perfectly set up to perform substitution to solve. However, we're told to solve by using elimination. So I'm going to have to rearrange this bottom equation so that it is closer to standard form like the top equation. So I'm going to add 3/4 x to both sides. Multiply both sides by 4. And now we see we have 3x plus 4y equals 12. Well, the equation that we're comparing it to is the same equation, 3x plus 4y equals 12. When this happens, you have infinite solutions because they're the same line. The lines completely overlap with each other. Lines are infinite amount of points long. So this one has infinite solutions.